It's easy to think of our planet as this solid, stable rock beneath our feet. But the truth is, it's alive. It's constantly in motion, a dynamic system of just incredible power. Today, we're diving into one of the most dramatic ways it shows us that power: earthquakes. We've all seen the news, the dramatic footage. But what is actually happening deep inside the Earth when an earthquake hits? What unleashes that kind of raw energy? That's the big question we're going to tackle. Okay, so to really get it, we've got to go deep. I mean, way, way down below the surface, because that's where this whole process kicks off with immense pressure and a sudden, violent snap. At its core, that's really what an earthquake is. It's not the shaking itself. That's just the effect. The cause is this massive release of stored up energy. Think about it like this. If you take a stick and keep bending it and bending it, you're loading it with energy. Eventually, it's going to snap, right? The shaking we feel is the planet's version of that snap. So, what's doing all that bending? Well, it's the tectonic plates. These are colossal slabs of the Earth's crust that are always moving, always grinding past each other. The thing is, they don't just slide by smoothly. They get snagged, they get stuck. And for years, decades, sometimes even centuries, the stress just builds and builds along those edges, what we call fault lines, until bang! The pressure just becomes too much. All right, this brings up two words you hear all the time in the news: focus and epicenter. The focus is the real ground zero. It's the exact point deep inside the Earth where that initial snap happens. The epicenter, that's the spot that gets all the attention, is just the point on the map directly above it. But remember, the real action always starts deep down at the focus. So, once that snap happens at the focus, all that energy has to go somewhere, right? It doesn't just stay put. It blasts outwards in every direction as powerful vibrations we call seismic waves. And here's the thing, not all these waves are the same. First, you get the P waves, or primary waves. They're the fastest, and they move in this kind of push-pull motion, almost like an accordion. Right behind them are the S waves, the secondary waves. They're a bit slower and move side to side. But the ones that cause the most trouble, that would be the surface waves. They are the slowest of the bunch, but they have this chaotic rolling motion that does the most damage. They are the real heavy hitters. Now, you might think it's all about those giant tectonic plates grinding together, and yeah, mostly it is, but that's not the whole story. The Earth can get shaken up for a few other reasons, and some of them are pretty surprising. I mean, just look at this. The vast, vast majority of quakes are tectonic. They are the giants, no question. But those other little slices on the chart, that's where things get interesting. For instance, you've got volcanic earthquakes, which happen when magma is moving around underneath a volcano. They're often a huge warning sign that an eruption might be coming. You can also get tiny quakes from things like mines collapsing, or even man-made ones from big explosions like nuclear tests. And, get this, we can even cause them by accident. The massive weight of water in huge reservoirs, like at the Koyna Dam in India, has actually triggered earthquakes. Okay, so we've got all this incredible energy being unleashed. How in the world do we even begin to measure it? Well, that's where a term we've all heard comes in, but maybe don't fully get: magnitude. And this is so important to understand, because the magnitude scale isn't like a ruler, it's logarithmic. That means a magnitude 6 isn't just one step up from a 5. Nope, it releases about 32 times more energy. And a magnitude 7, it's not just a bit stronger, it unleashes nearly 1,000 times the energy of a magnitude 5. It is a colossal, mind-boggling leap in destructive power for every single whole number you go up. And all of that energy has some serious consequences. An earthquake's devastation really comes in two waves. There's the immediate punch, and then there are the deadly chain reactions that can follow. So the primary effects, that's exactly what you'd imagine. The violent ground shaking and, in some cases, the surface of the Earth literally cracking open. But then you have the secondary effects, and these are often just as dangerous, sometimes even more so. An undersea quake can set off a tsunami. The shaking can trigger massive landslides. And then there's this really bizarre phenomenon called soil liquefaction, where solid ground starts acting like a liquid. And you can see how this becomes a terrible domino effect. First, the violent shaking hits. That shaking can cause soil that's full of water to lose all its strength. That's liquefaction. And what happens when the very ground your buildings are sitting on suddenly turns into something like quicksand? Yeah, catastrophic collapse.
one thing directly and devastatingly triggers the next.
Look, this all sounds absolutely terrifying, and it is. But the story doesn't just end with destruction. It moves on to understanding, to preparation. Because, let's be real, we can't stop the planet from moving, but we can absolutely learn how to live more safely with it. And a huge part of that is just knowing where the biggest risks are. You've got these major hotspots around the globe. The big one is the Ring of Fire. That circles the Pacific Ocean. That's where something like 90% of all earthquakes happen. But you also have huge collision zones like the Himalayas, or famous fault lines like the San Andreas in California, and many others. So what do you do if you're ever in one? It boils down to 3 simple life-saving words: drop, cover, and hold on. Seriously, that's it. Don't try to run outside. Get down on the ground, get under something sturdy like a desk or a table, cover your head and neck, and just hold on tight until the shaking stops. This simple drill saves lives. Period. So when you think about it, from the deep physics of the planet's core to the engineering of our buildings, understanding earthquakes is really about understanding our home. It's a powerful reminder that we live on this constantly shifting, dynamic world. And it leaves us with this big challenge, right? We can't stop the plates from moving. So the question is, can we get smart enough to build a world that's ready for them when they do?